Good morning, guys. So today we're going to start the last just tiny little notebook to finish up bonding. So the first type of bonding we did was ionic. Then we had metallic, which was just a short little lesson about that. Then we had covalent. Under covalent, we talked about there being polar and non-polar bonds. So this is a little bit different. This is polarity of the whole molecule. So whether or not the molecule now has a positive end and a negative end. Okay? So what factors make a molecule polar? So the idea of a pole is still going to be the same thing like we talked about in the last one, where it creates a positive and a negative end to it. But there's some other things that come into play now that make the whole molecule. Okay, so how do we determine the shape and the polarity of a molecule? So when determining the shape of the molecule, we are only looking at covalent compounds, not ionic. Okay, so we're only talking about covalent. So there's four major shapes that covalent molecules can have. There's other ones that you'll learn about later, but or if you take college chemistry or advanced college chemistry, the only four that we need to be concerned about are the four major types, which are a tetrahedral. So remember that when we have been talking about tetra, it's been a prefix of 4. So tetrahedral. We have pyramidal. We have bent and linear. So those are the four major types. So when we're going to be looking at the shape of it, the first thing we need to do is start with the Lewis dot structure. So same thing that we did in the last chapter, you're first going to look at what the electron dots look like. And then we're going to pay special attention. So the attention needs to focus on paired electrons. Okay, so the ones that are actually bonded. Or shared to another atom. And we're going to compare that to the electrons that are not bonded, which we called unshared or lone electrons. So remember we highlighted them in the last one whenever there was like an unshared pair. And so now that's going to come into play. I said when we did it that this would be important later. All right, so example 1. The first one we're going to look at is carbon tetrachloride. So this is one we've drawn before. So carbon tetrachloride, first of all, for us to think about what the formula for it would be. So carbon tetrachloride, tetra means 4. So our formula here is CCl4. So I'm going to go ahead and kind of do my rough draft. So I know carbon has 4 valence electrons. And chlorine has 7. So I know I need 1 carbon and 4 chlorines. So to draw my electron dot, I'm going to go ahead and put one of the chlorines at each of the spots. So I have carbon with 1, 2, 3, 4. I have chlorine with 1, 2, 3, 4, 5, 6, 7, and they share. 1, 2, 3, 4, 5, 6, 7, and they share. 1, 2, 3, 4, 5, 6, 7, and they share. And 1, 2, 3, 4, 5, 6, 7, and they share 1. So each chlorine has 7 of their own, share 1 and get 8. The carbon has 4 of its own and 4 that it shares to get its 8. Okay, so far we haven't really done anything new. All right. So now we're going to go ahead and we're going to look at the central atom. So the central atom is the carbon, the one in the center. Are there any lone pair electrons or electrons that aren't bonded to anything? So the answer is no. Each of those is bonded to something. So are those unshared pairs going to impact the shape? No. They have all of them, so they're not going to make it do anything different. Circle the shared electrons that form covalent bonds in blue. So I'm just going to go ahead and color them in a different color blue now. So these are the pairs of shared electrons. Okay. Redraw the molecule showing only atoms and bonds. Okay, so when we have carbon and we have 4 things that are attached to it, no unshared pairs or anything, that's going to be a tetrahedral shape. Okay, so there's no lone pairs. They're not going to impact. Circle the shared that form a covalent in blue. So we have 4 shared pairs. So whenever you have 4 shared pairs and no unshared pairs, your shape is going to be tetrahedral. Okay, so when we draw it, this is where you get to see my real artistic talent at play here. So we're going to have carbon in the center. And instead of it just making a cross shape, what it wants to do is these, if I only drew it flat like this in 2D, these chlorines would only be 90 degrees apart from each other. So what we actually create is a 3-dimensional one. So I'm going to draw 1 chlorine up this direction and 1 chlorine off to the side. And then what I'm going to draw to try to make it 3-dimensional and imagine is you're going to draw a squiggly line going back like this, and then one going like this, to try to show that these are actually like almost like little legs of like a little sprocket with a chlorine sticking out on the top. Okay. And you are going to do like a virtual lab so you can kind of see what I'm talking about with these. But this would be like if I had the carbon, I made these 3 legs, and then this was sticking out the top. So now instead of only being 90 degrees apart, like they would be up here, if we kept it flat, they'd only be 90 degrees. They're greater than 90 degrees now. Okay. And that's because these electrons that were actually around it are going to want to repel each other. So that's why we end up with an angle that's bigger than 90. They push themselves apart. So the molecule is based on its shape. We're going to think about whether it's polar or nonpolar. So since there aren't any unshared pairs and it's nice and symmetrical, we have a chlorine in the center, or carbon in the center, or chlorines around each of the different sides, this molecule is going to be nonpolar. And it's nonpolar because it's symmetrical and no unshared pairs. Okay, so the bond here is not what we're talking about now. This bond is polar. Okay, carbon has an electronegativity of 2.6. Chlorine has of 3.2. So these electrons are not going to be shared equally. So these bonds are polar, like we did in the last chapter, but the molecule itself is nonpolar. So it's a nonpolar molecule. With polar bonds. Okay? That's kind of a little bit weird to think about. And it'll make more sense as we do more of them, what makes something end up being polar. Okay, but the 2 things you're going to be looking for is that idea of it being symmetrical and if it has any unshared pairs. Okay? All right, so let's look at the next one. So that's a tetrahedral shape. So I'm going to go back up here first before we go. And tetrahedral has 4 unshared pairs. Okay? Or, sorry, 4 shared pairs. So the carbon had the 4 shared pairs. All right, so let's look at the next one. So the next one is ammonia. So ammonia, we see that the formula is NH3. So nitrogen, if we look up, has 5. So 1, 2, 3, 4, 5. Hydrogen, we know it has 1. So we're going to have our nitrogen in the center. 1, 2, 3, 4, 5. We know we need 3 hydrogens. So if we put 1 in each one of these spots, then we have our nitrogen that's in the center with 1, 2, 3, 4, 5 of its own. 3 that it's sharing, so that gives it 8. The hydrogen is 1 of its own, and then it has 2. All right, so now we're going to look through and think about what this shape will be. So circle the lone pair electrons in red. So lone pair electrons are electrons that are on the center atom that aren't bonded to anything. So this time we do have a lone pair. So are there lone pairs with the central atom? Yes. So that's going to impact the shape. Okay. Circle shared electrons that form a covalent bond in blue. So here's our shared covalent, here's our shared, here's our shared. Okay. So now we're going to go ahead and redraw the molecule showing only atoms and bonds. And then their lone pair electrons. Okay, so what happens here is if we have the potential to have 4 things, because there could be something here, but there's not. It starts off with the shape of tetrahedral. But then since it's missing its top, it becomes pyramidal. Okay? So because it's missing 1, then it becomes pyramidal. Okay? So when we draw it, we're going to draw it like we did in the last one. So we have our center atom. Instead of having the one on the top, it has those electrons. We have a hydrogen here, and then we have the one that's going back, and the one that's coming forward. So now we have this unshared pair up at the top that's going to impact the shape. So it can't be a tetrahedral because it's missing its top. So the name of the shape is pyramidal. And this lone pair of electrons is really going to kind of push these legs down. So now the angle is going to be a little bit smaller than it was for the tetrahedral. And because it has this unshared pair of electrons with that unshared charge, there's a lot of negative here, it creates a pole. So this shape is polar because it has unshared pairs. Okay, so anytime you have something like this, the unshared pair on the central atom, it's going to end up being polar because it creates this pole of a lot of negative charge up at the top. As far as the bonds, to think about what we did in the last chapter, if I look up nitrogen, nitrogen is 3.0, hydrogen is 2.2, so it's not being shared evenly. The nitrogen's kind of pulling it in. So we are going to have polar bonds. So we have a polar molecule with polar bonds. Okay, so this last one, tetrahedral, because it had all 4 spots on it, non-polar, because there weren't any unshared pairs, and also because it's symmetrical. The bond between the carbon and the chlorine was polar, because one had an electronegativity or attraction of 2.6, the other had 3.2. So they were sharing it unequally. The chlorine is kind of hogging them a little bit. So the chlorine is kind of hogging them a little bit. So the molecule is nonpolar because it's symmetrical and no unshared pairs, but the bonds themselves are polar. The one we just did starts off with the potential to be a tetrahedral, but it's missing its top. So as soon as you have an unshared pair, you become polar. And a tetrahedral that's missing one of its parts is a pyramid. So then it's polar because of these unshared pairs. The bonds, again, because the electronegativities are different, are polar. So this one is a polar molecule with polar bonds. All right, so that was a tetrahedral that's missing its top. Okay. All right, so now let's look at the next one. So very, very common molecule. If you know nothing else at the end of this course, I want you to know the shape and the polarity of water, because it is always, always, always something that you'll be asked. It's an academic all-stars question. It's a Regents question. Okay. All right, so let's go ahead and add to this front page here first, though. So pyramidal is when it has 4 on the central, but 1 is unshared or unbonded. Okay? All right. And again, these are the most common ones. There are other shapes as well. All right, so our third example is going to be water, which of course we know is H2O. So oxygen, if we look up, has 6. And hydrogen has 1. Okay. So when we go ahead and draw, we can see that if we share a hydrogen here and we share one here, then that's going to give each hydrogen 2. It'll give oxygen 6 of its own and 2 other ones. So oxygen is our central atom. So now there's 2 places where oxygen has lone pair electrons. So remember, we've been circling those in red. So there's our lone pair. And then the shared ones are these ones in blue. So what's going to happen with the unpaired oxygen electrons? So the unpaired ones are not going to bond. And they're going to repel each other because they're both negative. Negative, negative. So they're going to be pushing each other away as much as they can. They're going to be pushing these away as much as they can. So what ends up happening is we have 1, 2, 3, 4 potential sites. So it starts off that it could be a tetrahedral. But since it's missing not 1, but 2 now, so it can't be a pyramid, it's going to have a bent shape. And like I said, if you can remember one thing from chemistry, remember that water is bent. Okay. So now when we go ahead and draw it, we have our oxygen, and we have a hydrogen, and another hydrogen, and we have an unshared pair and an unshared pair. A lot of times it's written this way. Just because it's the way we represent it up and down like that. But we have, either way, we have 2 pairs of unshared pairs. Okay. So from the last question, you should know that right away, as soon as you have these unshared pairs, the molecule is going to be polar. And it's because it has lone pairs or unshared pairs. So If you remember nothing else, water is polar and its shape is bent. Okay, so those are two really important things. And again, if I were to look up their electronegativities, hydrogen's is 2.2, oxygen is 3.4. So the bond is also very polar. That's a big difference between those. So the oxygen is really hogging those shared electrons. So polar molecule, polar bonds. Okay. All right, and the last one we're going to look at is carbon dioxide. So we know carbon dioxide is CO2. So if you remember from the last one, carbon dioxide is kind of unique with the way it bonds. So carbon has 4, oxygen has 6. So each of these oxygens has 6. So we end up with kind of a unique situation. There's 4 on the carbon. And then when we go ahead and go to draw the electron dot, the oxygen has 6 of its own. We can share here. That's going to give them 7. But we also needed to share elsewhere. So I don't really like the way they put these dots in, but basically 1 from here is also going to share, and 1 here is also going to share. Okay, so carbon is our center atom, and it has an oxygen on each side. And here's our 1, 2, 1, 2. All right, so we're going to notice that the oxygen has lone pairs. So notice both oxygen have 2 lone pairs, but, that should say, is oxygen the central atom? No. Okay, so because the lone pairs are not on the central atom, it will not affect the shape. So these lone pairs here don't mean anything because they're not on the central atom. And that we already know. We saw that here. When we had the chlorine, these unshared pairs on the outside of the chlorine don't do anything. It's only on the center atom. Okay? So we're going to look at the electrons surrounding the carbon. So the carbon electrons, to start off with, the carbon by itself, are unshared or unpaired. So they're going to share with the oxygen electrons that are also unpaired, and they're going to form a covalent bond. And we end up with 2 carbon-oxygen bonds on each side. So in other words, we have 2 double bonds. So we circled those in blue. You had 1, 2, 1, 2. So this will give a molecule that has the same bonds and atoms on both sides. So we end up with a carbon in the center with a double bond to the oxygen and a double bond to the oxygen. So this shape is linear. It's not the only way to get a linear shape. You could also have a tetrahedral that ends up missing. If you have a tetrahedral that's missing 2 things, you can, actually no, because you'd have your unshared pairs. So linear is one of the shapes that you can end up with when everything's balanced on each side. So now, because you have the same thing on each side, the same bonds, this one is also going to be nonpolar. So just like how this one that we started off with was nonpolar because there wasn't any unshared pairs, it was nice and symmetrical. This one is also nonpolar for the same reasons. Because it's nonpolar because it is symmetrical and no unshared pairs. Okay. So the difference to notice between example 3 and 4. So example 3, the reason hydrogen and oxygen and hydrogen can't just make a nice linear molecule is because they have these two unshared pairs. They're missing the two pieces they're supposed to have. This one isn't missing anything on the center. Okay, so the difference to notice is that number 4, jeepers, number 3 does have unshared pairs. Number 4 does not. And those unshared pairs are going to change the way it is. If I look up the electronegativities of these two, carbon is 2.6 and oxygen is 3.4. So the bonds are going to be polar. So we have a nonpolar molecule with polar bonds. So just like how the first one was that we did. Okay. All right, so I know that's a lot. It's kind of a strange thing. Really all the electron dot stuff is all the same. It's really just once you draw the electron dot like you did in the last notebook, now you're just going to take a look to see, is there any unshared pairs? If so, then our molecule is going to be polar. Okay, and then you just have the 4 basic shapes. If it has 4 things attached to it, it's going to be that tetrahedral. If it's missing one of its parts, it's going to be a pyramid. If it's missing 2 of its parts, then it's going to be bent. And if it's got everything it's supposed to and just makes a straight line, then it's going to be linear. So bent is when there's 4 around the central, but 2 are unshared. Okay, so this was CCl4. This was NH3. This was H2O. And then our linear example we gave was carbon. Okay. All right, so what you guys are going to do is your very best to do as much of page 6 that you can. Okay, so the first thing you'll do is, what would the formula be? So if it's dichlorine monoxide, you'll write what the formula is. H2O, NH3, CCl4, okay, whatever the formula is. Then you're going to draw the electron dot. So these 2 pieces you should definitely be able to do. Then you're going to look, does it have any lone pairs? Is it symmetrical? Okay, if it has lone pairs, then it's going to be polar. Okay, and you can just write yes or no, polar, nonpolar. And then do your best to try to see which one of these it looks like that we did in the examples. Would it be a tetrahedral? Would it be a pyramidal, a bent, or a linear? Okay, so try your best. I know, again, like I've said, I'm not going to know necessarily whether you really do it or not, but it's to your benefit to try it first and then see where you went right. Plus, it's a lot for you to write down when we're going over it. If you have most of it done, then you can just fix and edit the things that you need to when I do the video to go over it. Okay, so good luck, and I'll talk to you guys later. Thank you.